arrangements of passengers who board the bus at the terminal. So the number of seating arrangements, you only have 5 seating arrangements, 5 seats available, 5 seats available at terminal. Let's write this a little better. Only 5 seats are available at terminal. So only 5 seats are available at terminal because people don't board the bus before the terminal. All right, only 5 seats are available at terminal because the people them go on the bus before the terminal. And so the number of seating arrangement at terminal is just going to be 5, 13 permute 5. That's going to be the number of seating arrangement possible at the terminal. 13 permute 5, which is 154,440. Nice and easy. So now it says at the first stop, no passenger will get off the bus. So nobody now gets up gone away. But there are 8 other persons waiting to board the bus. Among those waiting are 3 friends who must sit together. They are definitely going to sit together. So 8 people are waiting to join. So I'm going to draw 1, 2, 3. These are the 3 friends. Then they have to sit together. Then you have 5 people here. 1, 2, 3, 4, 5. So the number of possible groups of 5 of passengers who can join the bus. So there's going to be a group can be. So it's either 3 of them get to join and 2 person over here to join, or none of them here to join and everybody over here to join. All right. And so the number of ways is going to be, so the number of ways is going to be equal to either all 3 of them join, and if all 3 of them join right here, so choosing these 3 from these 3 times, we're going to choose 2 from this 3, from this 5, so choosing 2 from this 5, all right, plus, then if none of them here not join, then we're just choosing 5 from 5 here. So this would be 5, choose 5 times none of them from here, which is choosing 0 from the 3. All right, and that will give you the total number of possible groups of 5 people that can join the bus. It's either the 3 of them join and then 2 people over here, so, or everybody over here, so, and none of them over here, so, but the 3 of them from here have to go together after. So that's gonna be 3 choose 3 times 5 choose 2, that's 10, and 5 choose 5 is 1, and 3 choose 0 is 1, so it's 10 plus 1, 10 plus 1 is 11. That's the answer. Nice and easy. So next part of the question. Next part of the question says Gavin and his best friend Alexander are 2 of the 5 specialist batsmen on his school's cricket team. Given that the specialist batsman must bat before the non-specialist batsman and that all 5 batsmen may bat in any order, what is the probability that Alexander and Gavin are the opening pair of any given match? So this team, I like cricket, and this team, it said they only have 5 specialist batsmen I can tell you that they lose already. Unless they have a Virat Kohli and a AB de Villiers and a Chris Gale and a Kieran Pollard, then otherwise they're going to lose. Chris Gale, AB Pollard, Gavin and Alexander, that must be the top five because they only have 5 specialist batsmen. So they have maybe 2 all-rounders and 4 bowlers. That's not the best lineup. So 5 of them, all right here. And we need the possibility of Gavin and Alexander opening. So we need Gavin and Alexander opening. What's the possibility of Gavin and Alexander opening? All right. So now to choose these two. So first, that means for Gavin and Alexander opening, that means we definitely the probability of the 2 of them opening. So the probability of Gavin opening and Alexander, I'm going to call it Gavin intersect Alexander. The probability of 2 of them opening is equal to. That means we're choosing these 2. All right, we're choosing these 2 from 2 times. That means we're choosing none out of these other 3. So we're choosing none out of those 3 divided by the total probability, which is choosing 2 from 5. That will give us the total possible opening combinations. And so that works out to be 2 choose 2, 2 choose 2 times 3 choose 0 divided by 5 choose 2. And so there's 1/10. So there's a 10% chance Gavin and Alexander will be the opening combination. So there is a 10% chance Gavin and Alexander will open next match. There's a 10% chance. All right, nice and easy, soft. That takes care of this question. Okay. Now we get a matrix now. We have this matrix A, and they want to find the determinant of the matrix A. Our task: calculate the total outcomes in the sample space. So the total outcomes is going to equal to the number of outcomes on each coin, which is 2 times 2 times the number of outcomes on the die, which is 6. So that's 4 times 6, 4 times 6, which is 24. So there are 24 outcomes, 24 possible outcomes on the sample space. Since it's just 24, I could list out all of them. I'm feeling a little bit, feeling in the mood to list out all of them. 24 is not a lot, and so I could list them all out. Yeah, let's list them all out. The 24 possibilities, if I were to list them out, would be, you could have head, you could have head, and then a 1. You could have head, and a 2. You could have a head, and a 3. You could have a head, and a 4. You could have a head, and a 5. You could have a head, and a 6. You could have maybe those are all possibilities of getting a head, then a head, then a 1. Then maybe you get a head, then a tail, head, then a tail, then a 1. Maybe you get a head, then a tail, then a 1. Or maybe you get a head, then a tail, then a 2. Or maybe you get a head, then a tail, then a 3. Or maybe you get a head, then a tail, then a 4. Or a head, then a tail, then a 5. Or you get a head, then a tail, then a 6. Those are for right there. Or maybe you got a tail, then a head, then a 1. Or you get a tail, then a head, then a 2. Or you get a tail, then a head, then a 3. Or you get a tail, head, and 4. Or you get a tail, head, and 5. or you get a tail, head, and 6. Or maybe you're just not good and you get 2 tails and a 1, or you get 2 tails and a 2, or you get 2 tails and a 3, or you get 2 tails and a 4, or you get 2 tails and a 5, or you get 2 tails and a 6. All right, so that's what, these are all the possible outcomes. All right, all possible outcomes. So those are the 24 possible outcomes. If you wanted to show them like that. Nice and easy, soft. Now it says, find the probability of getting exactly one head. The probability of getting exactly one head from here is the chance of getting one head, as you can see, out of the 24. Well, exactly one head. So the probability of getting one head, so the probability, so it's pretty much asking you for the probability of getting one head. The probability of getting one head, that's just going to be equal to, on the first die, you'd have to get a head, which is 1 over 2. That's the probability of getting a head, times, you need to get a tail now. You need to get a tail. This would be the probability of getting a head, and the probability of getting a tail now, probability of getting a tail is a quarter, times the probability of getting anything else. So it's a chance of getting one head, chance of getting a head on the first die, all right, times the probability of getting a tail, times anything else, which is 1, plus the probability of getting a head on this, on the other dice, so it would be a half, times a half, times 1. All right. You might wonder what this half means. This just means probability of getting a head. Remember, you know, you have either head or tail, so there's a half a chance of you getting a head. So you can get a head, a tail, and then I put times 1 because it doesn't matter if you get a 1, 2, 3, 4, 5, or 6. Then over here, so you can get a tail, then a head, and say work this out and you get a quarter plus a quarter, which is a half. So there's a half a chance of you getting exactly one head. All right, and see it there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 out of 24 chances of you getting one head. Getting one head. All right, so there's half a chance of you getting one head. That's how you do it by calculation. This is by the sample space. It says calculate the probability of obtaining at least one head on the coin, obtaining at least one head on the coin, and an even number on the die. So they want this. The probability of getting one head and an even number. This is one head and even number, one head and even number, one head and even number, 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 head and even number. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So you could tell them from sample space, chance of getting one head and an even number is, from the sample space, you could tell them that the chance of getting one head and the even number is 9 out of 24. And 9 out of 24, that will work out to be whatever you want that to be. 9 out of 24, which is 3 over 8. All right, 3 out of 24. That's the probability of getting one head and an even number. Now, the next thing it asks for, well, let's say you didn't put out the sample space. I'm going to do the calculation for those who didn't draw the sample space. Let's say we're doing it by calculation. So the probability of getting one head, just for those who didn't do the sample space, once it's less than 30 sample points, I highly recommend drawing the sample space. But to get one head and an even number, all right, one head and an even number. The probability of getting at least one head is, these are independent events. The chance of getting at least one head is going to be, probability of getting at least one head, this would be 1, let's see, 6, 12, 18 out of 24. So the chance of getting at least one head is 3/4. All right, the probability of getting at least one head. You might wonder, how do I know that? Getting at least one head, you can either get tails, or you can get tails, which is one head, or you can get head, or you can get tail. All right. And so at least one head is going to be 3 out of 4. So it's 3 out of 4 if we get one head times the probability of getting an even number. There are 3 even numbers from 6 numbers. And so this simplifies down to be 3 into this 1 time, 3 into this 2 times, so you get 3 over 8. And that's how you do it. Any way you prefer to do it is fine. All right, nice and easy. Soft. Now let's look at part B. Part B says, determine whether C1x plus C2x squared is a solution to the differential equation x squared over 2y double prime minus xy prime plus y equal to 0.